and type 2, and also of type 3. So type 3 are wherein we add a new column for every changing attribute. So that is not commonly used. So we are going to focus on the type 1 and type 2. Now type 1, as we mentioned earlier, is simply updating the record. So overwriting the record is type 1. And type 2 is maintaining the history of the data by adding a new record and undating the already existing record. So what we are going to try to implement in our SSIS workflow today is basically we have some data that's related to the employees. So we have employee data. So for that, we already have a dimension table called the dim employee. And if we look at the data in this table, then there's some 10 records in this table. And we have something called the employee key. Then we have the first name, the last name, the title, the email address, phone, gender, start date, and end date. So these are the attributes that we have in this table along with the department name. Now we take a closer look at the data. We can see then we have the first name and the last name. The title is basically the job title, and all these attributes, the other attributes are either type 1 or type 2 that we have to decide. So the first step is to identify the business key in this table. Which columns are the key columns, the business key columns in this table for which we want to retain the history. Now we look over here on the left-hand side on the columns, we see that the employee key is an integer not null key, and that is most probably, so we can look at the script of this table. So if we go and do a script table as create to in a new query editor window. Okay, so we can see that the employee key column is actually an identity column. So it's like a primary key of the table or the surrogate key of the table. So identity basically means it's an auto-incremented column, and it is incremented by the SQL Server database itself. So the values are decided by the database. Now, since the values are decided by the database, it cannot be a business key because the database is generating the values for this column. So this is a key column, but a SQL Server specific database specific key column. So this is kind of a surrogate key. So it doesn't have anything to do with the business. It is a database generated specific key column. So what we are going to use as a business key are the first name and last name, based on which we are going to identify whether there is a new record. So if there is a record in our input which has a new combination of first name and last name, we'll be treating it as a new record and inserting that record in our employee table. If there's a record coming from the source which has the first name, same first name and last name as already existing in our dim employee table, then we are going to treat that as an update record, and we are either going to implement a type 1 update or a type 2 update for that record. So the business key that we have identified over here is the first name and last name. Now for the column title, so every time an employee changes, the job title of the employee changes, we want to track that history. So we will mark this as type 2 attribute because we'll be inserting a new record. If the title of the person of the employee changes, we want to implement and insert a new record. Email address, same. Likewise, for email address, we want to track the history for the email address, so we'll be marking it as a type 2 attribute. Phone, we are not really considered about the history of the phone number. So if an employee changes his phone number, we do not want to track the history. So we will mark this as a type 1 attribute, and we'll simply update the same record. So if this employee by the name of David Bradley changes his phone number, we're not going to insert a new record with the new phone number for this employee, but we are going to update the same records, the already existing record, with the new phone number. So this would be a type 1 attribute. Gender ideally should never change its value. So we are going to mark it as a fixed attribute which should not be changing its value. Department name, same way, is a type 2 attribute because we want to retain the history of the department name. Now these two columns over here, start date and end date, basically will help us track the history. So these are essential columns in a type 2 dimension, start date and end date. The end date basically tells us whether the record is the current record or any of the historical records. So if I look at these two records for David Bradley, I have got two records for David Bradley. The title remains the same, the email address remains the same, the phone number remains the same, everything else remains the same. Okay, so everything else remains the same in this, but the two records for this person, probably because they changed some other attribute and I have not included that attribute in this table. But anyways, the important thing over here is that one of the records is end dated on 11th of February 2009. So all the attribute values for this person, David Bradley, as I mentioned in this record, are valid only till 11th of February 2009. The current record for David Bradley, if I want to fetch the latest information for David Bradley, then I have to put a filter on my table saying where end date is null, because all those records which have an end date of null are my latest records. Any record which has been end dated is a historical record, and the time period for which that record was valid can be found by the start date and end date. So if I am trying to fetch any information for David Bradley between the period of 20th of July 2007 and 11th of February 2009, then I have to put the filter on start date and end date, where your date is greater than the start date and less than the end date, and then I would be able to fetch the information for that time period. So the start date and end date basically show the time period for which the record is valid. So this record for David Bradley was valid from 20th of July 2007 to 11th of February 2009. The next record is valid from the 12th of February 2009 and it's valid till today because it has not yet been end dated. So this is the latest record. Now, if another record comes from David Bradley and it has any of the attributes updated for which we are making the check, then another record should be ideally inserted if we are trying to update a type 2 attribute, and this existing record which has null in the end date should be updated with an end date and a new record inserted with end date as null. All right, so we'll be seeing all this. So this is going to be a DEM employee data. This is already existing data in the DEM employee table. My source data or the incremental load data. So when you are working in a real data warehousing project, then there would be an initial load of your dimension table. So the initial load of the dimension table is basically loading into an empty table. So you will have all new records loaded, or if you are trying to load the historical record, it would be a one-time load that would happen. That would be the initial load. Once you have data in your dimension table loaded initially, then on your frequency of updating the dimension, you would be loading some data from the source and at a fixed frequency updating your dimension table. So that becomes your incremental load. So you only load the new data that comes in for the dimension or any updates that come in for the dimension. If the record comes in for a dimension with the same information as already existing in the table, that record is discarded. So you need to identify the new record, any new record that comes in, new information that is coming in, or any updated information that is coming in. So that is your incremental load, because you're not loading the entire table, but you're only identifying the new information and the updated information and loading them accordingly. Now our incremental load source is in the form of a flat file. It's called the employee data. And if we look at that flat file, it looks like this. You have all these columns which are present in your dim employee table. So it's a comma separated file we can see. So it's a CSV file. And then the first row is the column names. So you have the first name, last name, title, email address, phone, gender, department name. So all these columns are present in your dim employee table as well. And then you have values. So we can see that there's some records. There's a record for David Bradley. So we'll see if it has some new information. If we compare this record over here, so if I open this and open my flat file over here and compare the David Bradley record, I can see that the first name and last name are the same. So this would be an updated record if there is any change in the value. The title remains to be the marketing manager, so there is no update over here. The email address is david01@adventureworks.com. So there's an update in the email address, which we are going to track as a type 2 dimension. So there should be a new record inserted. Then the phone number remains the same. The gender remains the same and the department remains the same. So here there's an update in your email address, which we are going to track as a type 2 dimension. Now, Adam Owens, this person does not currently exist anywhere in our dim employee table, so there should be a new record that is inserted. The third record is Kevin Brown, and then we have this information for Kevin Brown over here, marketing assistant. Then his email address remains the same, his phone number remains the same, and everything else remains the same for this person. So this record should not be updated, the Kevin Brown record, because there is no information that has actually changed for this person. All right. So now we have these three records for coming in for an incremental load. We will design an ETL process that should be able to identify the new record, which is this record over here, Adam Owens, and insert it as a new record with end date as null. And it should be able to identify the updated record, which is for David Bradley, and it should be able to end date the already existing record and create a new record with the new email address as the current record. All right, so we are going to design this ETL process. Now, to design this ETL process in SSIS, so we have opened a new package and a new project in SSIS. The first step obviously is to go to the control flow and design a data flow task, because we are dealing with the data over here. So just drag and drop a data flow task as always, and we can rename it to a meaningful name. So this could be a load dim employee. Okay, then just double click on it and we'll move to the data flow. Now the first step is to read here incremental source data. My source data is coming in the form of a flat file. So what I would need over here as a source is a flat file source, which is over here within the other sources. Just drag and drop it over here. This becomes your flat file source. And then configure it as we have already done previously. Just double click on it. There's no flat file connection manager. Create a new one. Click on new. Select your file name. So my file name is going to be the employee data. Say OK. Column names in the first data row, that is true. Go to the columns tab. See if the data is being correctly passed. It is. So we are okay. It has correctly identified the delimiter as comma. Advanced is okay for now. And this is going to be a preview. Okay. Retain null values from the sources, null values in the data flow. We'll just select that. We can do a preview again. There are no null values in the source, so we are okay. Say okay. So now I have configured my flat file source. Let me just go and close this employee data worksheet. All right. So again, I can just go and source employee. Rename this to a more meaningful name. Now, the next thing I want to do is to add another task, which is called the slowly changing dimension task, and it is present in the common transforms. So here it is, slowly changing dimension task. So what I'm going to do is just drag and drop and put my slowly changing dimension task. Connect the output from the flat file to the slowly changing dimension task. Now I can just again cd underscore dim employee. Okay. So this becomes my SCD transformation. Just double click on it. Now, if you double click on the SCD transformation or the slowly changing transformation, then this window will pop up. This is nothing but a slowly changing dimension wizard, and this will walk us through all the steps that are necessary to configure this transformation. So it also tells you basically what you need to do. So this wizard helps you to configure your data flow to handle a variety of slowly changing dimension types. So types are type 1, type 2, and it will mention them differently, which we'll see. And it tells us what we need to do. So you first select the dimension table, okay, that in our case is the dim employee table, and map its key columns to columns in the slowly changing dimension transformation. So we have to identify the business keys, and then you configure support for the slowly changing dimension columns. So all the attributes of the dimensions, how do we want to treat them, that we need to mention. And then you click next to begin configuring. Okay, so we click on next. And now we come over here, and this is a similar kind of screen that we have seen before. There's a connection manager. Now this is asking for a connection manager because we have to connect to the dim employee table. So it needs to know the database details. So we do not have anything currently. So we go to new. We already had specified the SSDT connection. So we just will select it. Then we need to select the table of view, which in our case is the dim employee. Okay. So now what we can see over here is, just a second. Okay. So now we have come on to this page that says a select a dimension table and keys. So we have selected the dimension table, dim employee. As soon as we have selected this table, it has given us the list of columns which are present in this table. And now it has specified all the columns and the key type as not a key column. Now here what it is asking us to do is to specify the business key for this table. So based on those columns, it will identify whether the incoming record is a new record or an updated record. Now we can also see that it has mapped all the input columns to the dimension columns. The input columns are the ones which are coming from the flat file source that we have defined. Now, it has not been able to map anything for the end date and the start date because there are no input columns which have the values for these. So these are derived columns. So that's why the input columns are empty for this. Now, all the columns which are specified as not a key column because it does not know which columns are the business key columns. But the first step that we need to do now is to specify the business key column. So we have mentioned earlier that the first name in our table is going to be a key column. So I'm going to just click on this over here on the drop down and select the business key option. And it's not just the first name which is the business key of my table. It is a combination of the first name and the last name. So I have to go to the last name column and then click on the drop down over here and select business key as well. Okay, so now I have selected my key column. So now I can just click on next and come over here. Now what the wizard wants us to do now is select a change type for the slowly changing dimension columns. So change type here, let us first add all the columns. So just click on this. It will keep on adding columns. So just click on all the rows. It will add all the columns that are present in my table, which are the non-key columns. So the first column it is added is a department name. Now, if I go to the change type and click over here, a drop down would occur again. And if I check the values in this drop down, then I have got a few options. So if I expand this like this, okay. And the options are fixed attribute, changing attribute, and historical attribute. Now, if you check on the left-hand side, you will see the details of what these terms mean. A fixed attribute is basically something defined by the wizard to be having constant value, and the wizard and the ETL workflow you might configure it to throw an error if there's any change in value encountered for this column. So a fixed one is basically for any attribute for which you are not expecting any changes. So a good example of this would be the gender column. So once it has been specified as male or female, we are not expecting any changes for this column. And if any changes do come, there might be a mistake. So we want to be aware of that, and we want to configure our ETL workflow to fail in that case. So we are aware that some invalid data has come into our system. So that's why we can specify it as a fixed attribute. So fixed attribute, fixed value, the value should not change for this attribute, and if it changes, I have the option to configure my SCD stage or task to fail the ETL workflow so that I'm able to catch that error. So the next one is going to be the changing attribute. A changing attribute is basically a type 1 change. So if there's a change in that value, for example, we mentioned that for phone number, we really do not want to track the history because that information is not any meaningful information for us. So what I really want to do is that if there's a change in phone number, I just want to go and be able to update my already existing record. So that becomes a changing attribute. An attribute whose value might change, but we just want to overwrite the value in that record. So that becomes a changing attribute. The third one is a historical attribute. That is a type 2 attribute. So basically an attribute for which we want to retain the historical information. For example, a department name. So if the department of the employee changes, we want to end the current record with the existing department name and create a new record with end date as null and the new department name. So that becomes a type 2 dimension, type 2 attribute or a historical attribute. So now for department name, I want to retain the history. So I'm going to define it as a historical attribute. For email address also, I want to retain the history. So I'm going to define this again as a historical attribute. For gender, as we mentioned, we want to mark it as a column. For which if the value changes, we want to be made aware of that because it might be invalid data. So I'm going to define it as a fixed attribute. Phone number, the value might change, but I do not want to track the history. So I'm going to define it as a type 1 attribute or a changing attribute. Title, again, the job title changes. I want to be able to track the history. So I'm going to define this as a historical attribute. Now, I've made this decision right now based on my understanding of the data, but when you're working on a real-time project, these things will be defined in your source to target mappings, which would be prepared by the data modelers, and they would be in agreement with the business users. The business users would tell the data modelers and the business analysts whether they want to track the information for this attribute or some other attribute, or whether they are expecting no changes in the values for a particular attribute. So all this information the business users would share, and the data modelers and the business analysts with their understanding, technical understanding, and the business understanding would be designing the source to target mappings, which are the basis for creating ETL workflows for the ETL developers. And there it would be mentioned whether this attribute is a type 1 attribute or a type 2 attribute, or this should be having fixed or constant values, and based on that, the ETL developer will be assigning these values over here based on what is written in that source to target mapping. Okay, so now we move on to the next. And then there are certain options over here for the fixed and changing attribute options. Now for the fixed attributes, this has the option to fail the transformation if changes are detected in a fixed attribute. So fixed attribute, as we have defined the gender column as a fixed attribute, do we want the transformation to fail, to be made aware of any invalid data? Then I can check this option. If I do not want it to fail, then I can uncheck it. So again, depends on the business requirement and what is mentioned in your source to target mapping. Then about the changing attributes. Change all the matching records, including outdated records, when changes are detected in a changing attribute. So this basically means, for example, we have defined the changing attribute, which is a type 1 attribute, as a phone number column. Now, if there are already existing records as in our table, so we already have 2 records for David Bradley. Now let's say the phone number for David Bradley changes and it comes as a new record in my incremental load. Then what do I need to do? Do I need to just update the phone number in the record which has the end date as null, so which is the latest record, or do I want to update the phone number even in the outdated record, which is the earlier historical record? So I have these options and I can check that. If I want, I can check that option by clicking over here. So if I want to update the phone number even in the already end dated record, then I can check this option over here. If I want to update the phone number only in the latest record, which is denoted by the end date as null, then I can leave this attribute as it is. Okay, so I can just leave it unchecked. Then again click on next, and then I have the options for the historical attributes. How do I want to handle them? Now there are 2 ways to handle the historical attributes, and specifically for this particular transformation. So I can either choose to have a current flag. Now I don't have a current flag in my table, in my dimension table, so I'm not going to use this option. But let's look at what are the options, what things need to be configured if you want to be using this option. So for example, if I did not have start date and end date in my employee table and instead had a column called the current flag, which would indicate whether the record is the latest record or it is some past historical record. So for example, if we go back to the data over here, then this record with employee key of 8 and end date as null would be having a column called the current flag column, and the value in the current flag would be Y or true or 1 or whatever, and all the previous records like this record would be having the current flag as no or 0 or false. So that is also one way of identifying the historical records. So the transformation gives us that option to use the current flag as an indicator of historical record. So if I had that column and I wanted to use that column, then so the option here is use a single column to show current expired records, column to indicate record. So you would have the option to choose, because then that column would have been present in your dim employee table, so it would have been listed here. You could have chosen that column. Value when current. So it allows us to have 2 kinds of values, whether current or true. And expiration values, it allows us to have either expired or false. So if you choose current over here, then the expiration value would be expired. If you choose true over here, the expiration value would be false. So if you have this column, the current flag column, and that is the column you are using to track the historical records, then you can use this option. On the other hand, if you do not have the current flag column, but you have the start date and the end date columns, and in most of the implementations, data warehouse implementations, these are the columns you would see instead of the current flag column, because the current flag column does not allow us to track the time duration during which the record is valid. So it doesn't allow us to track the history properly. It just shows us the latest record and the historical records. But the start dates and the end dates will give you the exact time durations during which a record was valid. So this is a proper tracking of the history of the record. So I have the start date and the end date in my dim employee table, and I'm going to use them to track the history. So use start and end dates to identify current and expired records. How do you want to track them? Start date column is my start date. End date column is going to be my end date. Now the next option that you need to select here is variable to set date values. So when a new record comes in, what value do you want to set for that record? So for that, you can create your own variable, or you have your list of variables, the system variables, which are the date time variables which you can use. So if I insert a new record today, I can use my system container start time. So basically the start time when the package is executing, I can use that and mark it as a starting point of my new record. So the start date would become, if I execute the package at, if the job runs, or if the workflow runs at, let's say, 12 p.m. every day, then the start time would be the 12 p.m. of that record for all the new records which are inserted. So I have this option to choose any of these variables to set the value. And for now, I'm going to use the system container start time. Then we click on next again. And now this is your Inferred Dimension members. So this is basically, you have an option for inserting the values and facts for which the dimension values have not yet been inserted in the dimension table. So those are called the inferred dimension, which are also denoted by the term the early arriving facts. So you have some, so you would be basically inserting some default values in your fact table for the dimension keys. For example, you don't have any record for that employee, but you have a fact record coming in for a new employee. So you'll be inserting the employee ID as -1, or the first name and last name as, let's say, blanks in the table. Those are known as inferred dimension members. So for inserting and seeing the whole inferred dimension thing, we need to create a bigger workflow with loading the fact and so on. So we'll see this option later on. So for now, let's just uncheck this. So enable inferred member support. We do not want that support right now. So let's just skip this part and go to next. And now we are almost at the end of the wizard, and it gives us the summary where it asks us to review the outputs that the slowly changing dimension wizard would be creating. And if there are any changes to be made, you can just click on the back button and make the changes and come back to the steps in the wizard again to this screen. So it has come with a summary that the following outputs will be configured for the slowly changing dimension. So for the new records, it would be configuring the new record output. For the other output, it would be configuring the historical attribute output. All right, so we'll see how this actually works off. So just click on the finish button over here, and this will complete your wizard. Now, as soon as you have clicked on the finish button over there in your wizard, you'll see that your transformation has automatically expanded, and there are a lot more columns which have been included in your transformation. A lot more tasks which have been included in your transformation, in your data flow task. Now this is a big package that has been developed automatically by SSIS now, because we were using the SCD wizard. So now if we look at this package closely, we'll see that there's your SCD dim employee that identified the two outputs for the historical attributes. This is for the changing attributes updates output, and then there's another output that the SCD has produced, which is called the new output. So it has produced three outputs: the historical attribute insert output, the changing attributes, this is simply an update, and the new output for the new records. which are entirely new record which need to be inserted in your dimension table. Now, if we go and check what exactly it has done, so it has created some code by itself. So if you go to the changing attribute updates output and click on this OLEDB command, so it has taken the connection. There are some component properties. If you go to the component properties and look at the SQL command over here, it has created some SQL command which needs to be updated. Now, if I click over here, I will see what exactly the SQL command is. So it is basically update the dbo.dim employee. So it is going to update the dim employee table and set phone number as whatever is passing through the input. So it is simply because we defined the phone number as a changing attribute, as a type 1 attribute. So all I want to do is basically run an update query on dim employee for all the records which are identified as having the changing attribute. So I'm just going to update the phone number simply by running an update query where first name and last name, so I have a matching record, and end date is null. This is because I chose that option that I do not want to update the outdated records with the new phone number value. So SSIS has wisely devised this code and put it into its SQL command. Then there are column mappings. It has created some parameters to map to the phone number. All right. So this is how SSIS generates the code on by itself based on what are the options we have selected in the SCD wizard. Now let's check for the historical attributes. What exactly is it doing? It has inserted a derived column transformation. Now if I click on this, so it basically derives column as we saw yesterday. It creates a new column that can be added to your input stream of data. So it has a new column end date. And in the source data, as we saw earlier, there were no mapping for the start date and the end date column because those columns are not coming from source data. They have to be defined as the new columns. And we specified in our wizard that we would be adding the time as a system container start time. So it has taken that over here. dt_db date over here is simply a typecast function. All right. So the typecast function basically which converts it into database date format. So this is your function. So it's basically casting the container start time into this data type. It has defined the data type itself over here as DB date. So the end date of the already existing records is being updated by the container start time. That is what is happening over here. So, okay, let it happen. Now, once this value has been derived for the end date, then it is going to execute an OLEDB command again. So again, if you go to the component properties over here and go to your SQL command, then you can see that there's a simple query being executed, which is update dim employees set end date equal to question mark. So end date is coming from the previous derived column transformation. The first name is this, last name is this, and end date is null. All right. So for the latest, already existing latest record, it is going to end date that record by passing the value of the end date column as derived in the derived column transformation. And then there's a new output coming, flowing in as it is, for which we do not need to do any transformation. So now what they're doing is they are merging the already existing records which need to be end dated with the corresponding new records using a union all transformation. So union all transformation is nothing but a union all in your database. So it simply combines the data from different sources, input sources, into one stream. So it's a basically union all combining the data from your two input streams. So they have the same structure. It is combining. You can just check it over here once. And then after that, it has inserted again a derived column transformation. And in this transformation, it is now deriving the start date. Start date is being derived using the same container start time that we defined in our wizard. Again, converting it to the dt_db date. All right. So now basically the two columns which could not be mapped from the input, the start date and end date, it has used the derived column transformations to derive the values for those columns using the variable that we specified, which was the system container start time. And then as the final option, it is going to insert this into the employee table. This is a table that we selected. And these are your mappings. This is how it is going to map your data. All right. And this is your error output. So end date, it is not mapping over here because for the already existing records, we have already updated. So it is a simple ignore over here. Employee key, it is not mapping over here because it's an identity column in the table and the value should be auto-generated by the database itself. But here if we see it's giving a warning signal that truncation may occur because it has read the column from the flat file, the gender column, and it reads it as a string 50, string of length 50, whereas in our database table, the gender column is defined as varchar 1. So that's okay for us. We know that no truncation would occur because our data is not like that. So we can ignore this warning, or we can actually go to the input stage, the source employee, and change the data type over here, or use the data conversion task to change the data type. Okay, so that is a task that can be used to change the data type to gender 1 from the flat file, and then we can do it. But this is just a warning which can be safely ignored, so it doesn't really matter. So now the next step is basically to save this package and then execute this package by clicking on start over here. So the build is fine, 0 errors and 0 warnings. And then there are tick marks over all the transformations, and it also says that the package execution completed with success, so it should have gone fine. It read 3 records from the employee flat file, passed them to the slowly changing dimension stage or task, and then there were no changing attributes found because the phone number had not been changed for any of the records, so no record flew through this path. One record went to the derived column part because there was one record which was an update record, okay, for David Bradley, so that needed to be end dated. And there was new output record. One record was an output record, so you have 2 new records inserted, 1 record updated in terms of end dated, and then there were no type 1 attributes identified. So let's just click on this to come out of the build mode. And now let's go back to the table and see what exactly has happened. So this is my query. This is my table. If I click on execute over here, now what basically has happened is that 2 records have been inserted into my table. As I can see over here, now there are 12 rows. Earlier I had 10 records in my table, and I can see that for David Bradley, now I've got 3 records. There's a new record with the employee key of 1002, which is system generated, so it has been randomly generated to be 1002. I can see that the first name is same, last name is same, the title is same, the email ID has been updated as was mentioned in my source file. Everything else remains the same. The already existing record, which was supposed to be the latest record, has been end dated with today's date. I can see that this is 9/6/2019. The new record has been created with today's date as the start date, and the end date has been marked as null to identify it as a new record or the latest record. This is exactly what we wanted. End date the already existing record, insert a new record, put the end date as null to identify it as the latest record, and put the new values because we wanted to track the history of the email address column. So now I have the history. Prior to 9th of June 2019, the email address for this person was david0@adventureworks.com, and now starting from the 9th of June, his email address has been changed to david01@adventureworks.com. Now, the other record that has been inserted, and it's easy to identify using the employee key because they have been generated as new set of numbers here. So this is your Adam Owens. This was a totally new record. So what we wanted was all the information inserted for this person and the end date inserted as null for this person. So this is exactly what has happened. A new record inserted because this employee did not exist before. So a new record has been inserted for him, and the end date for that record has been specified as null to indicate that this is the latest record in my dim employee table. Okay, so the transformation seems to have worked correctly by specifying all the options, and it has been able to derive all the values correctly. So this is not a complicated transformation at all. There are other ways to implement slowly changing dimension using the other transformation tasks in SSIS, which we'll see in one of our later sessions. But if you want to use this dimension and these are our requirements, then you can see that it's a fairly simple wizard to use. There's not much configuration that you need to do. You just need to specify your keys and whether your columns and attributes are type 1 or type 2. That is the only thing you need to specify. And all the remaining work is done by SSIS itself because it is wise enough to generate the code by itself. So this is a very easy transformation to use if you have a requirement to simply identify your columns as type 1, type 2, and you have start dates and end dates. So you have a typical structure for your dimension table, and in most cases, this is the structure of your dimension tables. You have a start date and end date, then you have attributes which you define as type 1 or type 2, and then you have your business keys. So in most of the cases, this transformation would be very valid. And as we already saw, the wizard makes it very easy because it helps SSIS to generate all the code itself. So we do not have to do any coding, any explicit coding. So important task and easy task, and it enables us to do a very important update in the database, which is updating the slowly changing dimensions. So this is about the slowly changing dimension task.